And this is the outline of my today's presentation. The first is the introduction. As we all know that coffee is a very important beverage all over the world, and chlorogenic acid, for short CJ, is one of the main phenolic compounds in coffee, which are believed to have antioxidant properties, and it can protect food from oxidative degeneration, and it can prevent various disease, and can contribute to the formation of taste and flavor of coffee beans. It also can protect against radiation. Based on all these functions we mentioned, we can conclude that clogged CJ is very important to human health. So it is necessary to detect the content of CJ in coffee, which are ready to drink. And before we drink coffee, green coffee beans need to be roasted. And CJ is easy to decompose at high temperature. CJ is easy to decompose at high temperature. If the temperature is too high, the CJA will decrease, and if the temperature is too low, the coffee won't taste good. So the objective of my research is to find a proper temperature for both high CJA remain and good coffee taste. After we drink coffee, there is coffee residue left, and according to other people, there is still a lot of CJ left in coffee ground, so it is also very important to detect the CJ in coffee ground. And next step, I will introduce the roast coffee bean. According to Specialty of Coffee Association of America, roast coffee can be divided into several degrees, and from the light degree to the dark degree according to the coffee color. But it is not a universal rule, because different countries have the different rulers, and different people have different personal taste. So, in my experiment, I want to find which condition is the best for people drinking. The best means it has high CJ content and have the good taste. High performance liquid chromatography, for short HPLC, is a common used method for detecting CJ in coffee, but HPLC is time consuming and complex sample preparation. So our research is use the spectrum to predict the CJ directly. In our lab, the spectral range is from the ultraviolet to the terahertz. Comparing to the HPLC method, spectral method is quick, simple sample preparation, and easy to realize online detection. The theory why we use the spectrum to detect the CJ because the spectral absorption is related to the molecular motion. Different molecular have corresponding spectral absorption, so we can use the absorption spectrum to identify the substance which we need to detect. But for example, for infrared spectral absorption, it is mostly related to the intramolecular force. For example, chemical bond vibration, just as the finger shows. The chemical bond vibration includes the chemical bond stretching vibration and the chemical bond bending vibration. And for terahertz spectral absorption is mostly related to the intermolecular force. It's a force between the different molecular. The intermolecular force is much weaker than the intramolecular force. And for coffee solution, it contains both intramolecular force and intermolecular force. So the ideal result we expect is comparing all spectral regions to find the most related information to predict the CGA. And this is the experiment device. This is the coffee roaster we use to get the different degrees of coffee. And this is the coffee grinder we use to grind coffee. And this is the HPLC system we use to get the reference value of CGA. And this is the spectrum device in our lab. This is all the device I use in my experiment. And sample preparation. After roasting and grinding, we will get the coffee powder. Then coffee powder was dissolved in the maximum and water mixture. The proportion of maximum and distilled water is 60 to 40. Then vibrating for 40 minutes, and the solution will be treated by filter paper, and we will get the filter liquids. The purpose of the extraction is used for future HPLC analysis. Then we will use the HPLC to get the reference value of CGA, and then use the device in our lab to get the spectra. This is the NIR spectrum, and clock CGA has a significant absorption peak at 324 nanometers in the UV spectrum, and it is caused by the pi electron transition on the benzene ring and the carbon chain. It causes the HOMO to LUMO transition at this part. So this part can identify this part. And at 1,215 nanometers, it corresponding to the second overtones of carbon hydrogen vibration in carbon hydrogen 2 group. It corresponding to this part. And at 2,018 nanometers, it corresponding to the bond of oxygen and hydrogen stressing and oxygen hydrogen deformation in ROH groups. Like this part. But the solvent in my experiment, I use the water and methanol. They also contain the hydrogen and hydrogen bond. So it is hard to discriminate this part and this part. So therefore, we need to use the chemometric method to find the collected information and remove the uncollected information to find the connection between the spectrum and the CGA. And this is the terahertz spectrum. As we all know that terahertz have a strong absorption in water. Have a strong absorption in water. According to the previous research, the water absorption peak is about 170 centimeter and 266 centimeter. But in my experiment, I use the water and methanol, so the peak shift from there to there. And because the terahertz have a strong absorption in water, so it means the intermolecular force between the water molecules between the water molecules is very strong. So if there is other substance was added into water, the intramolecular force will become weak. We can detect the substance based on this theory. And this is the result of my previous research. And from the table you can see Terho's result is not very good. The reason maybe my previous research I didn't control the temperature, because the temperature is a very important factor in Terho's region. So my next plan, I want to control the temperature as a constant. And for MIR, NIR spectrum, I want to find the wavelengths which contribute most to the CGA prediction. And I will get different roast degrees of coffee and continue on my experiment. That's all. Thank you.
Question? I asked to change the some graphs of the some spectral absorbance, some such a graphs. These numbers are very small, and it's important. Yes.
This is not important.
This is not important.
But the sample.
You don't need this. Why don't you erase it?
Oh, you don't need
Which one? I can't.
This is
Sample 10,
sample.
sample 11.
Oh, number. Not you.
But how do we distinguish this one? Sample.
Oh, this is overlapped.
Maybe because you directly import from Ascamble. This is from Ascamble. So I think it's better you transform to Excel, and so you can remove the sample name. So and then with X. Also no this upper no.
What's y-axis? What's this?
You never can put because they are Ascamble. So you have to convert to Excel.
First of all, you have to show me what's x-axis, y-axis. Then, how many? I don't know how many. But it's not easy to understand. Then last time I told you same thing. You don't remember? Then when you create this one this time, you discuss with someone how to make this kind of to get a better graph. You just draw.
She doesn't ask for me.
Yeah, hopefully you improve time by time. So next time you should do that, please. Otherwise, not so different. Last time I asked you to change to get a more better understanding. Please, next time. Any other?
In coffee, there are many other polyphenolics there. If you are only measuring intermolecular and molecular bonds, those bonds are also common to other phenolic compounds. How are you going to differentiate between chlorogenic acid and the other compounds in that matrix?
I think it depends on the chemical-metric method we choose. Maybe we need to use this method to discriminate which is the CJ, which is the other substance.
And then how do you know what compounds, by measuring chemometrically, how do you then correlate that to what you see on your spectral absorbance?
Sorry.
When you're measuring spectral absorbance, as you explained here, it is due to a certain bonding. But that bonding is common to many particular compounds.
Yes.
And if in your matrix of your coffee bean, this sample has ABC polyphenolics, but this one has DCA polyphenolics, then the accumulative result of those polyphenolics will determine how much absorbance, total absorbance there is at any one wavelength.
Because you mean like this part, CJ contains and water and methanol contain like other substance also contain this.
Yes.
Because it not only just depend on this part, it depends on all like this comparing all these parts to predict.
So you can be confident that it is specifically chlorogenic acid and not another polyphenolic.
Okay. Yeah.
I think the absorption spectrum in UV region seems to be saturated. So, is it valid data saturated than flat?
Is it?
Yes.
Top.
The top of the
Oh, this
spectrum
is
is flat.
Yes, maybe the several sample is saturated.
But that indicates the detectors of something has a limitation. So that data cannot be valid. And I have the other question. Please go to the next slide. Let me explain why the absorption peak at 170 wave number is shifted to the lower frequency. Can you explain why the peaks
This
are
is
shifted?
the peak. I think this is the peak of water absorption. But the solvent I use is the water and methanol mixture. So I think maybe this is the reason.
So couldn't you confirm another concentration of ethanol? For example, 20% or 40% or 60%. If you can do such an experiment, you can confirm the shift is derived from the ethanol.
I can talk next year.
Number 10.
Oh.
10.
Oh.
Sample. one is related to this one?
17, sample number 17. Sample number 17. Is that correspond to the highest one?
Yes. Oh, this one.
Can you tell me the concentration of CGA in that?
I can't tell you now. Maybe later.
So maybe also it's better you show us the different concentration, for example, high, low, and middle level of CGA, and so we can understand the typical spectrum of different CGA concentration in the, for example, NIR spectrum. So as mentioned maybe by Silaga, that yes, and what about the sample number 17? Something problem. Maybe you also can check by using serometric, using PCA to see if something problem with number 17. So it will be very dangerous if you put such spectra in your model. And then you mentioned that you may be difficult to distinguish the contribution of CS or OH from your CGA and your water.
Yes.
So you use the reference is air or water? Air. The reference for this reference.
What? Air.
Yeah. So why don't you use water next time, just to see that if your water absorbent can be removed, because you use water as reference. So you want to show only CGA in your spectrum, the absorbent of CGA, because you use pure solution of CGA. So hopefully because in terahertz you may not can remove the water absorbent because it's very high, very absorptive. So until now by using FPR we cannot remove. But I think using the system and you select maybe good cell, why don't you choose water as reference, and what happened with the spectrum?
Okay, I will try next time. Thank you.
Can you adjust the output level in the UV region?
Oh,
You can.
I tried last time. The UV result. You mean the UV result? I think the UV result is better than the NIR result.
No. UV region saturated. Share told us.
Region.
Saturated. But the level was
Saturated.
fully saturated.
Mm.
So can you adjust down? Is it possible?
It's a little hard. You made to hard. It's easy to saturate. Yeah.
But you have no way to. Is that true?
Parameter the parameter you choose. You choose the parameter of
Parameter.
in our device. The device we have two detector, PMT and PBA. So you choose the detector, the parameter for the. You choose. We understand the parameter.
I know parameter.
So different the parameter, yes, of course. Like number of scaling. So sometimes if you look the reference saturated, so don't continue that parameter. We have to adjust the parameter until we get not saturated reference. And after that, so you can take sample. I think there is red card, red sign in the software. If saturated, so it will be red. So it means you don't continue your experiment. Saturated, but light green, so you can continue.
You can separate UV region and the other region. UV region is the higher absorbance.
But this is a significant absorption peak.
I know, but we are talking about more precise data acquisition. Maybe several samples result no good. No data, just the saturated data. So why don't you separate? UV is UV. UV is UV. Then visible region and infrared. So you can you can just adjust later on data. That's easy. You understand what I'm talking? Yeah. Anyway, so please discuss more with your group, and I believe you can improve more. I think it's time. Yeah. Thank you very much.